للعالمين.
All right, so we are back. Among our goals now are to introduce a few more building blocks so that we can solve more interesting problems at the end, much like those that we began with. You'll recall from a few weeks ago, we played with this sort of two-dimensional Super Mario world, and we tried to print a vertical column of like 3 or more bricks. Well, let me propose that we use this as an opportunity to now tinker with some of Python's more useful, more user-friendly functionality as well. So let me code a file called mario.py, and let's just print out like that, the equivalent of that vertical column. So it's of height 3. Each one is a hash. So let's do for I in range of 3 initially, and let's just print out a single hash. And I think now Python of mario.py, voila, we're in business, printing out just that same pyramid there, or just that same column there. What if, though, we want to print a column of like some variable height where the user tells us how tall they want it to be? Well, let me go up here, for instance, and instead, how about we'll use, let's do this. How about from CS50 import, how about the getInt function as before? So it will deal with making sure the user gives us an integer. And now, in the past, whenever we wanted to get a number from a user, we've actually followed a certain paradigm. In fact, if I open up here, for instance, how about Mario 1.c from a while back, you might recall that we had code like this. And we specifically use the do while loop in C whenever we want to like get something from the user, maybe again and again and again until they cooperate, at which point we finally break out of the loop. So it turns out Python does have while loops, does have for loops, does not have do while loops. And yet pretty much any time you've gotten user input, you've probably used this paradigm. So it turns out that the Python equivalent of this is to do similar in spirit, but using only a while loop. And a common paradigm in Python, as I alluded earlier, is to actually deliberately induce an infinite loop while true, capital T, and then do what you want to do, like get an int from the user and prompt them for the height, for instance, in question. And then if you're sure that the user has given you what you want, like n is greater than 0, which is what I want in this case because I want a positive integer, otherwise there's nothing to print, you literally just break out of the loop. And so we could actually use this technique in C. It's just not really done in C. You could absolutely in C have done a while true loop with the parentheses, lowercase true. You could break out of it and so forth. But in Python, this is like the Python way. And this is actually a term of art. This way in Python is Pythonic. Like this is the way everyone does it, quote unquote. Doesn't mean you have to, but that's sort of the way like the cool Python programmers would implement an idea like this, trying to do something again and again and again until the user actually cooperates. But all we've done is take away the do while loop, but still logically we can implement the same idea. Now below this, let me go ahead and just print out for I in range of n this time, because I want it to be variable and not 3. I can go ahead and print out the hash. Let me go ahead and get rid of the C version here. Open my terminal window, and I'll run again Python of mario.py. I'll type in 3, and I get back those 3 hashes. But if I instead type in 4, I now get 4 hashes instead. So the takeaway here is quite simply that this would be the way, for instance, to actually get back a value in Python that is consistent with some parameter, like greater than 0. How about this? Let's actually practice what we preached a moment ago with our meowing examples and kind of factoring all this out. Let me go ahead and define a main function as before. Let me go ahead and assume for the moment that a getHeight function exists, which is not a thing in Python. I'm going to invent it in just a moment. And now I'm going to go ahead and do something like this. For I in the range of that height, well, let's go ahead and print out those hashes. So I'm assuming that getHeight exists. Let me go ahead and implement that abstraction. So define a function now called getHeight. It's not going to take any arguments in this design. While true, I can go ahead and do the same thing as before. Assign a variable n, the return value of getInt, prompting the user for that height. And then if n is greater than 0, I can go ahead and break. But if I break here, I logically, just like in C, end up executing below the loop in question, but there's nothing there. But if I want getHeight to return the height, what should I type here on line 14 logically? What do I want to return, to be clear? Yeah, so I actually want to return n. And here's another curiosity of Python vis-a-vis C. there doesn't seem to be an issue of scope anymore, right? In C, it was super important to not only declare your variables with the data types, you also had to be mindful of like where they exist inside of those curly braces. In Python, it turns out you can be a little looser with things, for better or for worse. And so on line 11, if I create a variable called n, it exists on line 11, 12, and even 13 outside of the while loop. So to be clear, in C with the while loop, we would have ordinarily had not a colon. We would have had the curly brace like here and over here. And a week ago, I would have claimed that in C, n does not exist outside of the while loop by nature of those curly braces. Even though the curly braces are gone, Python actually allows you to use a variable anytime after you have assigned it a value. So slightly more powerful as such. However, I can tighten this up a little bit. Logically, and this is true in C, I don't really need to break out of the loop by using break. Recall that or know that I can actually, once I'm ready to go, I can just return the value I care about even inside of the loop. And that will have the side effect of breaking me out of the loop and also breaking me out of and returning from the entire function. So nothing too new here in terms of C versus Python except for this issue of scope. And I indeed returned n at the bottom there just to make clear that n would still exist. So either of those are correct. Now I just have a Python program that I think is going to allow me to implement this same Mario idea. So let's run Python of Mario.py and OK, so nothing happened. Python of Mario.py. What did I do wrong? Yeah, I have to call main. So at the bottom of my code, I have to call main here. And this is a stylistic detail that's been subtle. Generally speaking, when you are writing in Python, there's not a CS50 style guide per se. There's actually a Python style guide that most people adhere to. And in this case, double blank lines between functions is the norm. I'm doing that deliberately, although it might otherwise not be obvious. But now that I've called main on line 16, let's run Mario.py once more. Aha! Now we get there. Now we see it. Type in 3, and I'm back in business, printing out the values there. Yeah. Sure, why do I need the if condition at all? Why can't I just return n here as by doing return n? Or if I really want to be succinct, I could technically just do this. The only reason I added the if condition is because if the user types in -1, -2, I wanted to prompt them again and again. That's all. But that would be totally acceptable too if you were OK with that result instead. Well, let me do one other thing here to point out why we are using getInt so frequently, this new training wheel, albeit temporarily. So let me go back to the way it was a moment ago. And let me propose now to take away getInt. I claimed earlier that if you're not using getInt, you can just use the input function itself from Python. But that always returns a string or a str. And so recall that you have to pass the output of the input function to an int, either on the same line or, if you prefer, on another line instead. But it turns out what I didn't do was show you what happens if you don't cooperate with the user, with the program. So if I run Python of Mario.py now, works great, even without the getInt function. And I can do it with 4. Still works great. But let me clear my terminal and be difficult now as the user and type in cat for the height instead. Enter. Now we see one of those tracebacks again. This one is different. This isn't a name error, but apparently a value error. And if I kind of ignore the stuff I don't understand, I can see invalid literal for int with base 10 cat. That's a super cryptic way of saying that cat is not a number in decimal notation. And so I would seem to have to somehow handle this case. And if you want to be more curious, you'll see that this is indeed a trace back. And C tends to do this too, or the debugger would do this for you too. You can see all of the functions that have been called to get you to this point. So apparently my problem is initially in line 14. But line 14, if I keep scrolling, is uninteresting. It's main. But line 14 leads me to execute line 2, which is indeed in main. That leads me to execute line 9, which is in getHeight. And so, OK, here's the issue. So the closest line number to the error message is the one that probably reveals the most. Line 9 is where my issue is. So I can't just blindly ask the user for input and then convert it to an int if they're not going to give me an int. Now, how do we deal with this? Well, back in problem set 2, you might recall validating that the user typed in a number and using a for loop and the like. Well, it turns out there's a better way to do this in Python. And The semantics are kind of there. If you want to try to convert something to a number that might not actually be a number, turns out Python and certain other languages literally have a keyword called try. And if only this existed for the past few weeks, I know. But like, you can try to do the following with your code. What do I want to try to do? Well, I want to try to execute those few lines, except if there's an error. So I can say except if there's a value error, specifically the one I screwed up and created a moment ago. And if there is a value error, I can print out an informative message to the user like not an integer or anything else. And what's happening here now is literally this operative word try. Python is going to try to get input and try to convert it to an int. And it's going to try to check if it's greater than 0 and then try to return it. Why? All of 3 of those lines are indented underneath the try block. Except if something goes wrong, specifically a value error happens, then it prints this. But it doesn't return anything. And because I'm in a loop, that means it's going to do it again and again and again until the human actually cooperates and gives me an actual number. And so this, too, is what the world would call Pythonic. In Python, you don't necessarily rigorously try to validate the user's input, make sure they haven't screwed up. You honestly take a more lackadaisical approach and just try to do something, but catch an error if it happens. So catch is also a term of art, even though it's not a keyword here. Except if something happens, you handle it. So you try and you handle it. So you sort of best effort programming, if you will. But this is baked into the mindset of the Python programming community. So now if I do Python of Mario.py and I cooperate, works great as before. Try and succeed. 3 works, 4 works. If, though, I try and fail by typing in cat, it doesn't crash, per se. It doesn't show me an error. It shows me something more user-friendly, like not an integer. And then I can try again with dog. Not an integer. I can try again with 5. And now it works. So we won't generally have you write much in the way of these try except blocks, only because they get a little sophisticated quickly, but that is to reveal what the getInt function is doing. This is why we give you the training wheels, so that when you want to get an int, you don't have to jump through all these annoying hoops to do so, but that's all the library is really doing for you, is just try and accept. You won't be left with any training wheels ultimately. Questions now on getting input and trying in this way? Anything at all? Yeah? Say that, oh, could you put the condition outside of the try block? Short answer, yes. And in fact, I struggled with this last night when tweaking this example to show the simplest version. I will disclaim that really, I should only be trying, literally, to do the fragile part. And then down here, I should be really doing what you're proposing, which is do the condition out here. The problem is, though, that logically, this gets messy quickly, right? Because except if there's a value error, I want to print out not an integer. I can't compare n against 0 then, because n doesn't exist because there was an error. So it turns out, and I'll show you this. This is now the advanced version of Python. There's actually an else keyword you can use in Python that does not accompany if or elif. It accompanies try and except, which I think is weirdly confusing. A different word would have been better. But if you really prefer, I could have done this instead. And this is one of these design things where like reasonable people will disagree. Generally speaking, you should only try to do the one line that might very well fail. But honestly, this looks kind of stupid now. It's just unnecessarily complicated. And so my own preference was actually the original, which was, yeah, I'm trying a few extra lines that really aren't going to fail mathematically, but it's just tighter. It's cleaner this way. And here's, again, the sort of like, arguments you'll start to make yourself as you get more comfortable with programming. You'll have an opinion. You'll disagree with someone. And so long as you can back your argument up, it's pretty reasonable, probably. All right, so how about we now take away some piece of magic that's been here for a while. Let me go ahead and delete all of this here. And let me propose that we revisit not that vertical column and the exceptions that might result from getting input, but these like horizontal question marks that we saw a while ago. So I want all of those question marks on the same line. And yet I worry we're about to see a challenge here because print, up until now, has been putting new lines everywhere automatically, even without those \n's. Well, let me propose that we do this. For I in the range of 4, if I want 4 question marks, let me just print 4 question marks. Unfortunately, I don't think this is correct yet. Let me run Python of Mario.py. And of course, this gives me a column instead of the row of question marks that I want. So how do we do this? Well, it turns out if you read the documentation for the print function, it turns out that print, not surprisingly perhaps, takes a lot of different arguments as well. And in fact, if you go to the documentation for it, you'll see that it takes not just positional arguments, that is from left to right, separated by commas. It turns out Python supports a fancier feature with arguments where you can pass the names of arguments to functions too. So what do I mean by this? If I go back to VS Code here, and I've read the documentation, it turns out that yes, as before, you can pass multiple arguments to Python like this, like hello, comma, David, comma, Malin. That will just automatically concatenate all three of those positional arguments together. They're positional in the sense that they literally flow from left to right, separated by commas. But if you don't want to just pass in values like that, you want to actually print out, as I did before, a question mark. But you want to override the default behavior of print by changing the line ending. You can actually do this. You can use the name of an argument that you know exists from the documentation and set it equal to some alternative value. And in fact, even though this looks cryptic, this is how I would override the end of each line to be quote unquote, that is nothing. Because if you read the documentation, the default value for this end argument, does someone want to guess, is \n. So if you read the documentation, you'll see that \n is the implied default for this end argument. And so if you want to change it, you just say end equals something else. And so here, I can change it to nothing and now rerun Python of Mario.py. And now they're all on the same line. Now, it looks a little stupid because I made that sort of week one mistake where I still need to move the cursor to the next line. That's just a different problem. I'm just going to go over here and print nothing. I don't even need to print \n, because if print automatically gives you a \n, just call print with nothing, and you'll get that for free. So let me rerun Python of Mario.py, and now it looks a little prettier at the prompt. And to be super clear as to what's going on, suppose I want to sort of make an exclamation here. I could change the \n default to like an exclamation point just for kicks. And if I run Python of Mario.py again, now I get this sort of, exclamation with question marks and exclamation points as well. So that's all that's going on here. And this is what's called a named argument. It literally has a name that you can specify when calling it in. And it's different from positional in that you're literally using the name. Let me propose something else, though. And this is why people kind of like Python. There's just kind of cool ways to do things. That's kind of a, it's a 3-line verbose way of printing out 4 question marks. I could certainly take the, shortcut and just do this. But that's not really that interesting for anyone, especially if I want to do it a variable number of times. But Python does let you do this. If you want to multiply a character some number of times, not only can you use plus for concatenation, you can use star or an asterisk for multiplication, if you will. That is concatenation again and again and again. So if I just print out quote unquote question mark times 4, that's actually going to be the tightest way, the most succinct way I can print 4 question marks instead. And if I don't use 4, I use n, where I get n from the user. Bang, like now I've gotten rid of the for loop entirely, and I'm using the star operator to manipulate it instead. And to be super clear here, insofar as Python does not have malloc or free or memory management that you have to do, guess what Python also doesn't have? Anything on your minds in the past couple of weeks? Doesn't have pointers. Yeah, so Python does not have pointers, which just means that all of that happens for you automatically underneath the hood, again, by way of code that someone else wrote. How about one more throwback with Mario? We talked about in week 1 this sort of 2-dimensional structure where it's like I claim like 3 by 3, a grid of bricks, if you will. Well, how can we do this in Python? We can do this in a couple of ways now. Let me go back to my Mario.py and let me do something like for I in range of, we'll just do 3, even though I know now I could use getInt or I could use input and int. And if I want to do something 2-dimensionally, just like in C, you can nest your for loops. So maybe I could do for j in range of 3. And then in here, I could print out a hash symbol. And then let's see if that gives me 9 total. So if I've got a nested loop like this, Python of Mario.py hopefully gives me a grid. No, it gave me a column of 9. Why, logically? Even though I've got my row and my columns. Yeah. Yeah, the line ending. So in my row, I can't let print just keep adding new line. So I just have to override this here. And let me not screw up like before. Let me print one at the end of the whole row just to move the cursor down. And I think now together, now we've got our 3 by 3. Of course, we could tighten this up further. Like if I don't like the nested loop, I probably could go in here and just print out, for instance, a brick times 3, or I could change the 3 to a variable if I've gotten it from the user. So I can tighten this up further. So again, just different ways to solve the same problem. And again, sort of evidence of why a lot of people like Python. There's just some more pleasant ways to solve problems without getting into the weeds constantly of doing things like with for loops and while loops endlessly.